All right, moving on to the next problem here. We'll take a look at 3.5 number 18. And in 3.5 number 18, they give us a function, which is s of t equals negative 6t squared plus 64t plus 192. And they tell us that a stone thrown vertically on Mars, vertically upward from the edge of a cliff on Mars, where the acceleration of gravity is only 12 feet per second squared, with an initial velocity of 64 feet per second from a height of 192 feet above the ground. The height s of the stone above the ground after t seconds is given by that function. So the first thing is determine the velocity of the stone after t seconds. So this first problem number 18, all we're going to do is basically determine the velocity function. So I'll actually write a here. This is part A. So I want to know what v of t is. Okay. Well, we know v of t is actually the derivative of the position function. So s prime of t. So we just take the derivative here. We get negative 12t plus 64. That answers part A there. Yes. And then part B, let's take a look at my notes here again, is when does the stone reach its highest point? So that's easy. You know, when you're throwing a stone, if I'm a guy over here, you know, throwing a stone up in the air like this, it reaches its highest point when that derivative is equal to 0, when the velocity is equal to 0. So essentially, you know, the velocity is on the positive side, the velocity is on the negative side, but when it's equal to 0 right here, when that slope is 0, that's when I've reached my highest point. So I really look for when it's equal to 0. So I'm going to take that velocity function, negative 12t plus 64. I'm going to set that equal to 0. So I'll set that equal to 0. And in this case, I'll get 64 equals 12t. And so t equals, let's see here. I could probably jump out of here real quick and grab a calculator, keep my annotations here. 64 divided by 12. 4 divided by 12 is like maybe 5 or something like that. Yeah, there we go, 5.33. All right, go back into my annotations here. So this is going to be at 5.33 seconds. Let me get rid of just this part here real quick. Pointer options, let's get the eraser. Not sure. Oh, that's because I annotated. That's right. Pointer options, pen. So I'll do like this. I'll go like this. T equals 5.33 seconds. So that's when it's going to reach its peak. 5.33 seconds after I throw it. C is what is the height of the stone at its highest point. So height now again is position is what it is. So part C will be based upon the position function, or s of 5.33. That's what we're really looking for. So if I plug this in, I get negative 6 times 5.33 squared plus 64 times 5.33 plus 192. And if you work the math on that, I've got it worked out on my sheet here. That comes out to 362.67 feet. Okay, that'd be my answer for part C there. Part D then, when does the stone strike the ground? So when the stone strikes the ground is when we're setting the position function equal to 0. So up here I set the velocity function equal to 0 to determine when it was at its peak right here. Now I'm going to set the position function equal to 0 because when I'm on the ground, the position function crosses 0 here and here. Unfortunately, it's going to cross 0 at negative time here because I threw it at time t here. So let's take a look at that. So what we do is we take negative 6t squared plus 64t plus 192. And we could use the quadratic formula to solve this. You know, I prefer to solve this one with graphing. I think it's going to give us the easiest look at this too. So I'll go back into the into our Desmos calculator, and let's see here. Let's go back. Y equals negative 6t squared is what we had. It's number 18 plus 64t plus 192. 64t plus 192. And again, you could easily do this with your graphing calculator. I want to change the settings here a little bit so I don't have such a huge x-axis here. Let's go to negative 100 to positive 100. Let's go back here. There we go. 100. Hit enter. And you'll see one of these. So this is a function of time. So I have two potential answers when it would be at the 0 here. Negative 2.441 or 13.108. Well, let's see if we get negative 2.441. Get these written down here. Or 13.1. Okay. So these are my two possibilities when that would be equal to 0. It would be equal to 0 at t equals negative 2. I gotta look here again. 44. Just go out to a couple decimal places here. Or t equals 13.11, I think is what it was. Those are both in seconds again. But it's worth noting that this one doesn't make sense. That's going back in time. This is when it's going to strike the ground. T equals 13.11 seconds. And then finally, part E. With what velocity does the stone strike the ground? Well, that's actually pretty easy too. Really, all we have to do is go back to our initial velocity function and look at it for the time at which it strikes the ground. So we go v of 13.11 equals negative 12 times 13.11 plus 64. And so in this case, I've got it worked out over here. E is equal to negative 93.2 feet per second. And again, it is negative because we're going downward direction right here now is what we're doing. We're heading down. So negative 93.2 feet per second.